So in this lesson, we are going to talk about lines and segments that intersect circles. So you already know some of the lines and segments that intersect circle. The first one is a chord. A chord is a segment whose endpoints lie on the circle. So for example, on the figure you have A and B, and if you join any 2 points on the circle, it is a chord. And the next one is a secant. A secant is a line that intersects a circle at 2 points. It's a line. A chord is a segment, and if you extend that segment, it is going to be a secant. So a secant is a line. So that is the difference between a chord and a secant. A chord is a segment, a secant is a line that intersect the circle in 2 points. So it intersect the circle in 2 points. And a tangent is a line in the same plane as the circle that intersect it at exactly 1 point. So this C is called the point of tangency. C is called the point of tangency. So the point where the tangent and a circle intersect is called the point of tangency. So just go back and review the vocabulary words. We have chord, secant, tangent, and let's look at the next figure. We have like some common, you already know that we have a diameter. Diameter is like the distance between two, so the segment that joins any 2 points through the center, and diameter is a chord. Diameter is a chord, but all chords are not diameters, but diameter is a chord. And radius, the distance between or the segment that joins the center and any point on the circle, that is a radius, and this is secant and tangent and the chord. And let's go over the vocabulary word one more time. Chord can be a segment into, and it intersect a circle in 2 points. Intersect a circle in 2 points. And diameter is a segment that intersect the circle in 2 points. And radius is a segment that intersects the circle in 1 point. And secant is a line that intersects the circle in 2 points. And tangent can be a line, ray, or segment it intersects the circle in 1 point. So those are the vocabulary words you need to know before we go to the theorems and doing the problems. So let's move on. So let's look at some more vocabulary words here. So they said two circles are congruent circles if and only if they have congruent radii. So if you can, so you need to pay attention to the symbol for circle. So they just put a circle and a center, and they name the name of the circle is the name of that center, which is A. So that you need to read circle A congruent to circle B if segment AC is congruent to segment BD. If the radii are congruent, that means the circles are congruent. Segment AC congruent to segment BD if, so that is the converse of that statement if circle A congruent to circle B. So those are congruent circles. So if they have the same radii, we call those circles as congruent circles. Now let's move on to the next one. Concentric circles. Concentric circles means concentric circles are coplanar circles. They should lie on the same plane with the same center. So concentric circles are if you draw a circle with a radius 2 and with the same center, if you draw another circle with radius 4, they are concentric circles. So like this, and there is another circle there. They both have the same center. So concentric circles are circles with the same center and they lie on the same plane. Two coplanar circles that intersect at exactly one point are called tangent circles. How do you know they are tangent? Because they touch each other exactly at one point. They intersect at exactly one point. So there are two possibilities. You can have one circle inside the other circle and touch at one point, or you can have two circles externally touching at one point. So internally tangent circles and externally tangent circles. So those are the vocabulary words so far. So let's move on. Go back and review all the vocabulary words. Now we are just going to do a problem first. So let's look at the problem. They asked you find the length of each radius, identify the point of tangency and write the equation of the tangent line at this point. So what are the radius here? Find the length of each radius. So this is the circle. Radius is just 1 unit. So circle C, if I am looking at circle C, radius R equal to 1 unit. And circle D, radius R equal to 1, 2, 3, 3 units. 3 units. Then find the length of each radius. So that we already did. Identify the point of tangency. So this is the point of tangency there. And write the equation of the tangent line. So the tangent is parallel to the x-axis and it goes through y equal to 1. So the equation of the tangent line is equation of the tangent line is y equal to negative 1. Y equal to negative 1. That is the equation of the tangent line. Y equal to negative 1. Because it goes through negative 1 and every point on that tangent line has the y coordinate equal to negative 1 and it is parallel to the x-axis. Okay, we forgot to do one part on this. They said find the length of each radius, so we did that. That was eraser. Okay. So 1 unit, we did 1 unit, 3 unit, and they said identify the point of tangency. We didn't do that. What is the point of tangency? Point of tangency is this. So that means what are the coordinates of that? So you need to write that. Point of tangency is, what are the coordinates of that? 1, 2, 3 on the x-axis and negative 1. 3 comma negative 1, and that negative 1 is this because y equal to negative 1 is parallel to the x-axis, and that is the equation of the tangent line. So let's move on. So they are going to talk, they are talking about common tangent. How do you draw a common tangent to two circles? So a common tangent is a line that is tangent to two circles. So you have like two different cases here. Line L and M are common external tangents to circle A and circle B. So you can see they are touching at one point on both the circles. Like lines L and M are common external tangents. And here in this figure, line P and Q are common internal tangents to circle A and circle B. So those are the common internal tangents. So when you look at this figure here, tell how many common tangent circles have and draw them. If you have a circle like this, if you have one circle like this, and if they are not touching at any point, and another circle internally like this, you have 0 common tangents. And if you have the second case, part B is, what if you have two circles this? One, you can draw one external tangent like that. Only one external tangent. What if you have so what if you have two circles like this, separate circles? So you can draw 4 common tangents, 2 internal and 2 external. So you can draw, so this is how it is, 2 internal and 2 external. So you can draw like this. I'm sorry, it has to touch at only one point, so it's better to look at the figure that they give you. So you have 2 internal and 2 external common tangents. So you need to remember that. So there are 4 different cases. So the first one, part A, you have no common tangents. Part B, you have only one, and that is that figure. And part C, you have only 3 different cases. 4 common tangents you can draw if you have 2 circles like this. So that is common tangents. So the next part of, so we are done with common tangents. Now we are going to go to the first theorem, that is theorem number 1 about the line and the radius, a tangent and the radius. So let's look at the theorem first. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So if a line, so for example, this line is tangent to the circle, and if you can join the center and the point of tangency, that is the radius. So the radius and the tangent will make right angle, or they are perpendicular to each other. So if you have a point of tangency and if you have a radius from that point of tangency to the center, those two will make a right angle, or they are perpendicular to each other. So L is a tangent of circle A and L is perpendicular to segment AB. That is the first theorem. Second theorem is, if a line is perpendicular to a radius of a circle at a point on the circle, if a line is perpendicular to the radius of a circle at a point on the circle, then the line is tangent to the circle. So if you want to prove a line is tangent to the circle, you just need to prove it makes 90 degree with the radius from the point of tangency. So M is perpendicular to CD at D. M is tangent to, line M is tangent to circle C. If line M is perpendicular to segment CD at D, then line M is tangent to circle C. So those are the two theorems. We will prove that. And the next one is, the third theorem is, if two segments are tangent to the circle from the same external point. So A is the external point. If you draw a tangent from A to the same circle, then the segments are congruent. These two segments are going to be congruent. So segment AB and segment AC are tangent to circle P. That means segment AB is congruent to segment AC. The next one is a problem. Now you can see, find ST. That's what they want you to figure out, ST. So it's pretty clear, because there is an external point S and they drew tangents to the same circle. So that means the segments are going to be, that means segment ST is congruent to segment SU. That means ST is equal to SU. The length of ST is equal to SU. So Y minus 4 equal to 3/4 of Y. That's an equation with variable on both sides. So you just need to bring all the variables together, and we can add 4 to both sides first. Add 4. So it is Y minus 3/4 Y. We can add 4 and subtract. I'm just doing that in one step. Hope you understand. Is equal to 4. So 1Y minus 3/4 Y is 1/4 Y is equal to 4. So Y is going to be 1/4 of a number is 4. So the number is going to be 16. So Y equal to 16, but that's not the answer. So ST is Y minus 4. So that means 16 minus 4, which is 12 units. So you need to pay attention to the question, because sometimes if it is a multiple choice, they will give you 16 as an answer, and as soon as you get the value of Y, you think, oh, that's the answer, I got the answer. No, you need to look back and see what they ask you for. They asked you for the length of ST, which is Y minus 4. Substitute and find the answer. The next one, number 12, the question is, identify each line or segment that intersect each circle. So you just need to identify all the line or segments that intersect each circle. So do I have any segment DE and segment AC? Segment DE, or not segment, I'm sorry, line DE, and asking you to identify each line or segment that intersect the circle. So first let's see, do I have any chords? Yes, I do, because chord is the segment that connects any 2 points on the circle. So I can say segment DE, and chord is always a segment, so I need to take 2 endpoints. And segment AC is a diameter, but it is a chord also. So segment DE and segment AC are the chords. And do I have any secant? Secant is any line that is intersecting the circle at 2 points. So I can see line DE, and I can say line AC too. If I extend AC, it is going to be a secant. And what is the diameter? Diameter is going to be segment AC. It's a segment, it's not a line, segment AC. And tangent, do I have any tangent? Yes, because CF, line CF meets the circle at 1 point, which is C. And do I have any radii? Yes, segment BC and segment BA, and B is the center of the circle. So those are the segments and lines that intersects the circle. So we identified everything. The next problem, let's move on to the next problem, number 26. So in this problem, they just gave you this angle is 42 and they want you to figure out what is Q. And you see, like, there are 4 vertices. So that means it's a quadrilateral. What is the sum of the interior angles of a quadrilateral? Sum of the angles is equal to 360 degree, because it's, what was the formula? Sum of the angle is equal to n minus 2 times 180, right? Or you can divide this into 2 triangles. So that means 180 plus 180, which is 360 degree. Do I know any of those angles in the quadrilateral? So if I look at the quadrilateral, I can see I know angle P. Angle P is going to be 42. Angle P is 42 plus any other angle? Yes, because RP is a tangent and this is a radii. So we learned that this angle is going to be 90 degree. And this is a tangent, PS is a tangent and QS is a radii. So this angle is also going to be 90 degree. So 42 plus 90 plus 90 is equal to 360 degree. So that means, oh no, I'm sorry. We forgot measurement of angle Q, because there are 4 angles. We took 3 angles and the 4th one is angle Q. Measurement of angle Q plus 42 plus 90 plus 90 equal to 360. So measurement of angle Q will be, you subtract 360 minus what is the sum of this? 180 plus 42, right? So 180 plus 42, 222. So 360 minus 222, and that is equal to is that the one? 138, right? 138 degree. So measurement of angle Q is 138 degree. That's an obtuse angle. Now the third theorem is prove 11-1-3, which is like if you draw a tangent from an external point to the same circle, so those two segments are going to be congruent. Given AB and AC are the tangent to circle P, you need to prove segment AB is congruent to segment AC. That is what you need to prove. So they already gave you a plan for you guys. Draw auxiliary segments segment PA, segment PB and segment PC. Show that the triangles formed are congruent, then use CPCTC. All the auxiliary lines, so they want you to draw PA, PB and PC, all those three segments. So you can see there are two triangles. So let's prove those two triangles are congruent. So let's take triangle. So our goal is to prove. So what do you know first? Let's look at what you know first, then prove it. So we know segment PA is congruent to segment PA because reflexive property of congruency. And we know segment PB is congruent to segment PC because radii of the same circle. So we got two sides. Oh, then I know angle PBA or ABP is equal to measurement of angle PBA is equal to measurement of angle PCA is equal to 90 degree because that is the first theorem, right? 11-1-1 because the tangent and radii are, tangent is perpendicular to the radii. Perpendicular to radii. Then now we know triangle PBA is congruent to triangle PCA by HL theorem. Hypotenuse leg, because this is the hypotenuse of two right triangles, because this is right triangle, and we proved the hypotenuse are same because it's reflexive property, they are congruent, and another side, that is the radii, are also congruent. So HL theorem, then you can say segment AB congruent to segment AC by CPCTC. Corresponding parts of congruent triangles are congruent. Now let's look at the next problem. They wanted you to figure out DE. So this one, this is what they want. Let's say that's Y. What do you know? You know that there is an external point here, and you are drawing tangent to the same circle. So that means AE is equal to AC. A is equal to AC. So that is like 23 plus x minus 5 is equal to x plus y. Now you can just subtract x from both sides, and 23 minus 5 is 18 is equal to y. So that was easy. Y is equal to 18 units. That's the next problem. And the last, not the last one. Okay. Number 34 is circle M has center 2, 2. So if I'm plotting that on a coordinate plane, x, y, 2, 2 means 1, 2, 1, 2. So that's one center. Okay. And radius 3. Radius 3 means it's going to be 1, 2, and one more. So that is like a circle. This is the center M, and this is the radii 3 units. That's the first circle. Second circle, so first circle is going to be like this, right? And second circle is, to get an idea, I'm just plotting, it's not that neat. N is negative 3, 2. So that means this is negative 1, and negative 1, negative 2, negative 3, and negative 3, 2. So that means here, that's negative 3, 2. That's N. And find the, and is tangent to circle M. So that means it's tangent to circle M. So that means it will touch circle M in one point like this. So they are like basically on the same line. And what do they want? Find the coordinates of the possible points of tangency. So we already know the point of tangency has a y coordinate too. And what are the what are the possibilities for the next one? So that means this is this distance between this is 3. So this one is what? 2, 2, 2. This is 2, 2. So if they are straight like this point of tangency would be negative 1. So that's one possibility. Other side, because from here if I go 3, that's going to be 5. So 5, 2. So that can be 5, 2 or negative. So that is the point of tangency. So that's kind of logical. This one or 5, 2. There are two possibilities. Okay, let's move on to the next problem. Okay, so we are going to do this problem, and they said a bicycle chain is pulled tightly so that Mn is a common tangent. Mn is a common tangent to both the gears. So this one and this one, and find the distance between the centers. So they want you to figure out that. That's P. So what I did is I just drew that on a different sheet. Like I said, to find the distance between the centers of the gears represented by the points L and P, divide the region into a rectangle and a triangle. That is not quite seen here, since this is a bigger circle. So this is the center of that circle. So so if I drew a straight line like this, I will get a rectangle and a triangle. So this is 1.8 inches and this is 17.6. So this is also going to be 17.6. And by using this triangle, this is 2.5 because it's 4.3 minus 1.8, because the total was 4.3. That is the radii, and 4.3 minus 1.8 is 2.5 inches. So when you use the Pythagorean theorem, you will get LP squared is equal to 2.5 squared plus 17.6 squared. So I was calculating that and I got 17.8 inches. The distance between the centers of the gears is about 17.8 inches. So the distance between here and here is